Hello and welcome to an applied episode by solidassembly.com. Today we're going to create a 3D replica of an iPhone case using top-down design and surfacing techniques to make a co-molded plastic and rubber phone case modeled on something I stumbled across on the web. So right along, we'll do this in a few episodes, installments if you will. This is episode 1. We'll set up the skeleton part and build the base part geometry for the iPhone case. So let's get started. Up on screen here, I've got an iPhone that I modeled on a engineering drawing that I found on Apple, specifically for the purpose of making cases for the iPhone 4S. They published a PDF with all the required dimensions and such. So I modeled me an iPhone as a part in SolidWorks here. So there's a couple different ways to use this part as a skeleton. One would be to just start putting geometry right on top of it in this part file here. Another would be to actually insert this part into a new part using the insert part command in the destination part. And that would bring in a copy of the solid geometry as well as planes. I think you can bring sketches and various other datum geometry as well. And I think I'm going to do it that way. For a part, a skeleton that's expected to change a lot, especially a base part that's expected to change a lot, you're probably better off building right in this part to use it as a skeleton. Just right where the insert bar is, or a rollback bar here. Just start building your skeleton right on top of the features that are already here. There's a couple reasons for doing that for a part that could be expected to change a lot. First and foremost is, if you're going to be copying geometry from this using surface offsets or what have you, if there's any changes that you have to make to what amounts to the base part that cause feature failure, it'll happen in this part rather than in a part inserted into another part. As you'll see here in a minute, when I insert a part into a new part, there's no feature data really that's brought with it. All that's brought with it is a geometry read of the part itself. So any failure would be really difficult to troubleshoot for someone else. Having said that, this isn't going to change. This is an iPhone 4S. It's going to stay right there because there's nothing to change on it. It's all controlled by somebody else. So it basically approaches a library component. With that in mind, I think it makes perfect sense to take this part, push it into a skeleton part, and then begin building on the imported geometry. So let's do it. Make a metric skeleton part. We'll save this. iPhone case skeleton. One thing you'll learn if you ever have a PDM system is to tag things with their project somehow, or name everything a part number so that you don't have duplicate parts when you go to put it into PDM. But that, in this case, is neither here nor there. So, I've got my skeleton. Let's insert that part. So, I've got the iPhone 4S. And I can move it around here, but I want this to be on the origin to take advantage of the planes and such that are already in the iPhone part. So let's bring the solid bodies. We'll bring the planes. Unabsorbed sketches, of which there aren't any. And that'll be about enough. So if I do that and hit OK, I now have a blob, similar almost actually to a step import, but with datum geometry, in my skeleton part. So there you have it. Time to get started. So when I'm doing anything that could be expected to change a lot in surface geometry, particularly with stuff that may or may not be rectilinear, if you will, And you know, if I bring up the case on screen here, we can tell that this is definitely not rectilineal. You know, you got kind of this weird swoop going on. You've got an interesting intersection going here, going on here. This section right here is going to be a little bit of an interesting challenge to do, no matter how we slice it. So what I want to do is do the work once, and then if I have to, I can reorder things to make it work. Now, we could probably get there using solid body operations in SolidWorks, but you know, I think I'm going to stick to surfacing on this guy, and we'll see how it goes. I think it'll be really robust once we finally get it dialed in. So to start doing that, I'm going to take and we are going to do surface offset, select tangency. We're going to build the inner wall of this guy. So let's hide that for now. And we are going to do a surface extend. No. Surface untrim. Surface untrim. There we go. And surface untrim. There we go. We patched that surface up nicely. And if I turn back on planes, you know, the planes from that solid geometry are still there. So let's set up some geometry here first. So we've got the top and the bottom. What we also need to do is put in a couple planes here. It'll pick that. Let's say 3 millimeters. And we'll pick that, 3 millimeters. All right, so plane 10 is going to be case top bound, if you will. And this will be case bottom bound. So then in equations, we will need a case overall, whoops, thick, and that's going to equal 3 millimeters. Then we'll do a case over mold thick, and we're going to do that times 0.5. We'll just, for now, we'll make the case as thick as, or half as thick as the overall thickness. So the co-mold will be half as thick as your overall case. So then we want to do, so we can get out of that, and then let's equals global variables case overall thickness. So we want to plug these planes in so that they are intelligent as well. Equals case overall thickness. All right, so we've got some intelligence built now. So now that I've got those going, let's reorder these a little bit to make a little more sense here. So now we will do a surface extend. We'll select tangency, and then we'll go up to that surface. Then we'll do another surface extend off the bottom. Actually, I picked the wrong surface. That's okay. We'll get it in a second. Select tangency, up to surface. We're going to go down to the bottom. This one needs to go just to the iPhone top. And we can change that later because we may have to offset it. But that'll make it pretty easy to deal with later. So then we're going to need a couple copies of this. So first of all, we are going to need an offset of this. Whoops. Select tangency of, we'll set that arbitrarily to 1.5 for now. We'll hook it up in a second. Select tangency of 3. So there's a couple offsets. This one first here is going to be, he's going to be equal to case overmold thickness. because that's the surface we'll use to construct a cutting surface later on. And then this guy is going to be equal to case overall thickness. There we go. Although I probably don't want to do that one just yet, but we'll sit on it. So let's see here. We can start folding this around our iPad here. So actually I think what I'll do is I'll end up using this guy as my inner wall. So we got to build this inner lip, so how it tracks in around the screen here, and then we got to bring the outer wall up. So this one is already kind of there. Yeah, so let's do this. Let's take and do a plane off of here. It goes up 1 millimeter. Let's do an extend tangency to surface. Select tangency up to surface. He's going to go all the way up to the case thickness. Actually, he needs to go up to the top bound as well. 3 millimeters might be a little aggressive. So then let's do a surface fill. Okay, so then we'll do a surface trim. Actually, not that yet. So now let's trim this surface up to the top of the iPhone. So let's do another trim. Let's pick that plane and remove that. Then we do another patch. And then we do another trim. All right, another patch. Select tangency, merge result. Do another one of those on the bottom here. Now, a patch leaves me a little more vulnerable than sketching a planar surface, but I don't think the outsides or the perimeters of these are going to change much, so it's a risk I'm willing to take in this case. Alright, so now we can do a knit to grab all those and merge it down into one body. So there's the basic shape of my iPhone. If I bring that up and set that like so, I can see that I've put a little bit of a case around this iPhone. So now that we have the basic shape in play, we need to make some changes to it so that we can start with a shape that's as close to the PDF as possible. So there's a chamfer here, a chamfer on the inside lip, and then a fillet on the back side of the corner. So unfortunately, one downside of using surfacing is that SOLIDWORKS does not permit the chamfer tool to work on surfaces. which is annoying, but it just means that we got to sweep it ourselves. So if I pick that and make my own plane there, oops, not yet. Then because I want to have these planes drive me, inner chamfer start, inner lip inboard side, we'll say. Alright, so I'm going to make a chamfer across this. I want to avoid using edges if I can. Alright, so then we do pin this sketch down pretty good. And then let's see what happens when we pin it down to that plane that I created earlier. That's probably a little big. I don't think I want to do that. Let's instead, let's measure that and do, you know, like 1, just as a round number. Alright, so there I have my sketch. And then I'm going to sweep a surface using that sketch. Grab the selection manager, pick the edge, grab the tangency. Alright, there's that. It's kind of large. Okay, so then we need to cut a chamfer around the outer edge too. So since these arcs are concentric, then we'll just do another sketch on this same deal after. Let's see, I need a plane defining the outside. Again, SOLIDWORKS doesn't allow using a perpendicular surface, geometrical surface. So this is going to be the case westbound. SOLIDWORKS unfortunately doesn't allow using a perpendicular geometric surface to a sketch as a reference. It won't even let you pick it. It wants to use the edge. So I like to use the planes created coincident to those geometrical, or geometry planes rather, to allow me to, come on, to allow me to constrain sketch geometry to them. I believe that's more robust than using edges. Alright, this actually looks like it's a little bit steeper of an angle, so we'll do 45. And then let's do 1 again, just for giggles. Alright, so now we do another swept. Selection manager, grab the tangency, and done. Alright, so we need to cut this up, so let's do a couple surface trims. We will select other, grab that body, and we're going to remove that. Let's do another trim. That's not what I wanted. There we go. Now it's worth noting that select other behaves a little differently, in my opinion, in a surface feature than it does in most others. If you try to select just the surface with a select other, it won't grab the whole body, which I guess as long as you know. So I'll use the list to grab the whole body. So then we can knit all these together. I missed one. There we go. So I shouldn't have any blue edges. In my color scheme, blue edges mean single-sided edge, meaning the surface isn't knit together. So there, now we've got a halfway decent looking case here. So this is what I would consider to be the starting point for the I guess the best way to say it would be the overall shape of the case. So now when doing a co-mold, of course, you already know that we have to have rubber and plastic in close concert, and we have to model that so that the mold shop knows what to do for material flow, gating, building the mold, and so on and so forth. So we have to cut this shape up in a manner that reflects how we want the plastic and rubber to go. Now, on this fine case here on screen here, the white is going to be a cold mold rubber, so an injection grade rubber of some sort, and then the blue is going to be a plastic to form the rigidity and the backbone of the model or of the case. So we need to generate a surface or sets of surfaces that allow us to cut up the solidified shape to give us a rubber side and a plastic side. So there's a couple ways to go about that, but I think the most direct way is going to be adjusting this knit first of all. So we're going to take off that surface. And we're going to leave it just like that for a second. And the reason I want to do that, if I turn on a quick section view here, if I turn on a quick section view, we can see here that this section's looking a little fat, but that's okay. Oh, it also reminds me that we forgot to do our fillet. So let's do a fillet on this surface. Probably not quite that big. So let's say it's going to be about like yay. And then we'll do another one, small one on the inside surface. Actually, let's get the top one too. There we go. So we can see already that those fillets easily clear the iPhone. We don't want too much of an interference there, even though they are rubber, so it wouldn't matter that much. Okay, so now the reason I didn't knit that surface together just yet is I want to use it for something else. So we're going to grab that whole surface body and we're going to go 1.5 out with it. So this is going to be equal to case I'm going to guess that it has to do with these fillets. So let's make those a little bigger. Yeah, it is the fillet. I'm not sure why though. I bet it has something to do... Okay, so what it's doing is it's deleting that face. Okay, well that's alright. We can get back to that later. Important part is we have this bottom fillet, and it doesn't look like we're going to be anywhere close to cutting through the upper surface up here. That's really what we're after. So then I want to take and... So then I can finish my knit. So I can take him and knit together. And then we need to do an extend. Select tangency. And then we need to go up to this top surface, because we'll be using that later to cut things apart. Yeah. Alright, so now we have our base shape, and then we have a cutting surface suitable for making either one side or the other of our base shape. So let's go label this. So first of all, this was the overall base shape. That feature created it. You'll notice if you come up here to surface bodies, it updated the name of that to the last feature that touched it. In this case, the overall base shape. So then if I take this surface extend, well, let's label this first. Full mold, cutter, initial, and then coal mold, cutter, extend. Then we have a couple of surfaces that we can use. So first of all, I need to make 2 copies of this overall base shape. I don't want to use my original yet. There's a lot of reasons for doing that in surfacing, but I won't touch on them just yet. You'll probably see them as we go along. So I want to do an actual surface copy. So 0 offset. We'll do one of those, and we'll do another one. You can note in the feature tree, the select other actually highlights which one you're about to copy. I want that one. Okay, so we're going to call this one base shape copy. And we'll call this one base shape copy 2. All right, so first I want to make the plastic cut shape. So for instance, let's get rid of everything we're not going to use here. And now I actually need to make a copy of this surface body. I need to make 2 copies of him. I try to use the original. In this case, it's showing me the initial. That's okay. Try to use the original instead of making offsets of offsets, because then if I accidentally delete one in a feature tree cleaning rage, if you will, I won't accidentally completely screw up the model. So this will be coal mold cutter copy 1, coal mold cutter copy 2. Alright, so let's hide off those ones again. That one and that one can be hidden away. So let's make the plastic. So the first step to do here, and we can do this all in mutual trim, or should be able to. We'll pick the two ones we want to cut off of each other, and we want to remove the little lip sticking up and anything inside. So if we look at this now, if I turn on the body, you can see we're stepped back quite a bit here. Well, remember, that's because this is the plastic outer shell. The coal mold is all inside of this. If we go look at the PDF, the coal mold is all inside of here and is the only thing that touches the iPhone case. So that's actually what we want. So let's hide him off. That is going to be the plastic base basic shape. Alright, so we got one piece done here. So now let's go get coal mold cutter copy 2 and base shape copy 2 and show those. So now we're going to do another trim. We'll leave this one in mutual again. Pick those 2, and now we're going to remove the outer and the little lip. And hit enter. Now mutual trim automatically knits the surfaces together. So now if I unhide my plastic basic shape, these should be a line fit now, and it looks like they are. How slick is that? So this is going to be the rubber basic shape. That is pretty cool. Alright, in our next installment, episode 2, we'll put in the windows in the top and bottom of the case, and of course the sides as well. And then we'll take a look at how we want to create these cutouts in the side. Thanks for following along, and see you in episode 2.